Okay guys, so we have been working on electron configurations, and we just did the POGL where we had the electron configurations and we were setting them up like the hotel with the bunk bed situation, okay? And what we did was we learned that there were a few rules with setting up electron configurations, right? You have to start off at the lowest energy level, you have to fill an entire orbital before you can move into the next sublevel. So you have to fill one sublevel before you move into the next one. And every orbital within that sublevel needs to have one electron spinning up before you can add another electron that's spinning down. And that leads into the last one where you have to have your electrons spinning in opposite directions so that way they can not repel each other. Well, you can actually use the periodic table itself in order to determine what that electron configuration should be. So how do we do that? Well, there's a couple things we need to do to set up our periodic table first. All right, the first thing is helium is kind of in the wrong spot for this. So I'm just gonna put a little X through helium and move it over here next to hydrogen. All right, so I have helium next to hydrogen. Now I'm going to color some of these blocks. All right, now the first block I'm going to label is I'm going to color in, and I'm just going to use red for whatever reason, is the first two groups, group 1 and group 2. And I'm just going to color them in with this red color. Just and there we go. And I colored this group in red because this represents my S block. So anytime I'm writing the electron configuration for any of these elements over here in the S block, I can see exactly how many electrons there are in each orbital for that S sublevel. For example, if I were to write the electron configuration for helium, starting at energy level 1, 1s, and then there are 2 blocks, so that's 2 electrons. So my electron configuration for helium is 1s2. Now I can continue this because S isn't obviously the only sublevel. I have the P sublevel as well. So if I go down a row here, go down an energy level, by energy level 2, I now am talking about the P orbital. So I'm going to grab a different color here. Let's go with green. And I'm going to fill in my whole P orbital. So groups 13 through 18. So this is my whole P block. Again, each box here is representing 1 electron. So like boron would have 1, carbon would have 2 electrons in its P block, nitrogen would have 3 electrons in its P sublevel. So if I were to write the electron configuration for, say, oxygen here, I'm starting up at the top because I always start at the lowest energy level, and I'm going to count how many electrons I have in each block. So here we go. We've got first energy level, S2. Am I at oxygen yet? No, but I need to include those. So my first section is going to be 1s2. Now there's nothing along that first energy level again, so I'm going to go down to the second energy level, 2s12. Still not at oxygen, but I'm going to include that, so 2s2 is also a part of my electron configuration. I'm going to slide all the way across, and now I'm going to go into that P block. Second energy level, but now I'm in that P block here. So 1, 2, 3, 4. It's 4 electrons into the P block in order to get to oxygen. So now I'm going to write that as 2p4. And there's my electron configuration for oxygen. And we can keep doing this all the way through with the D and F block as well. I wouldn't ask you to do those on a test, but just for the sake of showing you, right, the D block is going to be in the middle here. Let me get pink. This right here is our D block. So all of our transition metals are in our D block. D is where it gets a little weird because this is actually energy level 3, 4, 5, and 6. So if I were to write the electron configuration for something that included a D orbital, for example, if I were to write the electron configuration for, let's say, gallium, that would come out to be 1s2, right? 2s2, including all of 2, 2p6, because I need to include all of that second energy level, 3s2, 3p, all of them, so that would be 3p6, 4s2, 3d10. So D actually starts on the third energy level, but because of how many electrons there are, that energy puts 4s a little bit underneath 3d. So it's kind of funky, which is why I'm not really going to ask you guys to do that right now, but I'm just showing you for example's sake. But when I go back over to the P block, I'm back in energy level 4. So that's 4p1. So that would be our electron configuration for gallium. And then finally, we have our lanthanides and actinides at the bottom. Excuse me. And that would be our F block. Okay, so whenever you go to write an electron configuration, or if you're going backwards and trying to figure out the electron configuration for an element, all right, you're going to want to start at energy level 1. And you're going to want to count every electron that's included in that block. I would highly recommend coloring in a periodic table like this, even if it's not your hard copy of your periodic table. It will really, really help you in trying to determine what the electron configuration is for certain elements, as well as if you're given an electron configuration, it will allow you to determine what element that is. If you have any other questions, please shoot me an email or come see me during intervention time.